Hello, ladies and gentlemen. Root Beer here, and I'm going to be starting another one of the Manitoba Math Contests. This time it'll be the year 2017. So if you'd like a copy of this contest, and I do try and encourage you guys to practice these contests on your own, you can click the very first link in the description, and it will get you a copy of this contest. So it's 2017 MMC, or Manitoba Math Contest. 2 hours. It's for students in grade 12. It's written the same day as the Pascal, Cayley, and Fermat from Waterloo, and I like this idea. They give something for the grade 12 students to do as well on that day. Things to note in general: calculators aren't allowed. You need to explain everything. 10 questions on the whole thing. It's a nice little contest. I like these, and as usual, I'm just going to go question by question, video by video. So in this one, we're just going to take a look at question number 1. So 1A, in how many ways can $20 be changed into dimes and quarters if at least one of each type of coin must be used? Okay. So $20 changed into dimes and quarters. Well, $20 is really 2,000 cents, and dimes are 10 cents, quarters are 25 cents. And we need at least one of each type of coin used. Okay. So, I think the first thing probably is to get an expression for $20 in terms of dimes and quarters, and it doesn't even have to be one that has both. I mean, we'll settle that we'll settle that constraint in a little bit. But if we just have the number of dimes, and remember that those are 10 cents, and the number of quarters, and remember that that's 25 cents. And that we want a total of $20, and that's 2,000 cents, because there are 100 cents in each dollar. Okay? So I'd start out making a little chart like this. Now, really quickly, if I want 2,000 cents just in terms of, say, dimes, 200 dimes would do just fine, and 0 quarters. Okay? That's not that hard to find, but that doesn't satisfy our condition of we need a few quarters kicking around. Okay. Well, could we ever have just 1 quarter and some dimes? I mean, that would certainly satisfy the conditions they want, but can we add up to 2,000 cents? Well, no. Anytime you have a quarter, you're going to have 25 cents and then some number of dimes. I don't really care how many. But it's going to be 10 times n dimes. Well, this is going to end in a 0. But this here ends in a 5. You're never going to have an odd number of quarters. We have to have an even number of quarters. Once we make that connection, then we say, okay, well, could I have 2 quarters? 2 quarters is 50 cents. 50 cents, well, that's 5 dimes, so just get rid of 5 dimes. And yeah, that adds up. 195 dimes and 2 quarters is $20. Okay, now we could, take away 2 more quarters. Or, sorry, add 2 more quarters and then take away 5 more dimes. Okay, we can keep doing this. And we can keep going until we get to the very bottom of the chart and we can express our $20 purely in quarters. Now, there's 4 quarters in every dollar. $20, that would be 80 quarters, but that would be 0 dimes. And while that is $20, it's not one of the ones that we want to allow, because we need to have at least a dime and at least a quarter. So what would be before that? Well, take away 2 quarters, and you can add in 5 dimes. And all of these will work, and in fact, these are the only ones that will work. As soon as I specify a number of dimes, if it has to add up to 20, it's very quick algebra to figure out how many quarters. Okay. So if these are all the possibilities, then we just need to count them. And I'd probably count by the quarters, 2, 4, 6, all the way up to 78. These are the ones that work. Okay. So we're counting by even numbers from 2 to 78. So I'd say it's 78 minus 2. Divide by 2 because we only want even numbers, and then add 1 because we're subtracting off 2. We need to include this little 2 fellow here. So it'll be 76 divided by 2. That will be 38. So 38 plus 1. There's going to be 39 ways to do it. Another way we could count, count 0 to 80. From 0 to 80, there's, 2, 4, 6, 8 up to 80 is going to be 40 numbers. And then we add once for the 0 that we didn't count, 41 minus the 2 cases that don't work, you still get 39. So 39 is going to be our answer. There's 39 ways to do it, and we have explained it with a nice little chart. Okay. Now, one also had a part B. What does part B say? A box contains 5 nickels and 5 dimes. 2 coins are selected at random. What is the probability that the total value of the selected coins is less than or equal to 15 cents? Okay. So we got 2 coins, and we have the same number of nickels and same number of dimes. Now, what sort of things could we draw? Okay. And sometimes I find people have problems setting up a probability question like this. They'll say, oh, you can take out 2 dimes, you could take out 2 nickels, or you could take out a dime and a nickel. So there's 3 possibilities. All right, and then we can say, all right, well, what's the probability that we get this? What's the probability that we get this? But I find it's a lot easier if you actually say, okay, I'm going to take out my first coin, and give, is that a dime or a nickel, and then take out my second coin. And when we break it down like this, we have 4 possibilities. 2 dimes, dime and a nickel, nickel and then a dime, or 2 nickels. And I think it's a lot easier to compute probabilities that way. Okay. So, we could have dime selected and then another dime. We could have a dime selected and then a nickel. We could have a nickel selected and then a dime. Or we could have a nickel selected and then another nickel. Now, these add up to 20 cents. Dimes and nickels, those are 15 cents. And 2 nickels is 10 cents. Okay? And what did we want? We wanted the total value being less than or equal to 15 cents. So we only care about the probabilities of these 3 outcomes. Well, what are those probabilities? If I reach in, what's the probability that I'm going to get a dime for my first coin? Well, there's 5 dimes and a total of 10 coins. 5 out of 10 times, I'll take a dime. Same thing with the nickels. But then it's a question of, okay, what's left? Once I've taken out this dime, there's only 9 coins to pick out of. If I've removed a dime, now there's 4 dimes and 5 nickels, so it's 5 out of 9 times I'll pick a nickel. If I take out a nickel, then I'm left with 5 dimes and 4 nickels, 5 out of 9 again. But if my first coin is a nickel, suddenly there's 4 nickels left, so it's 4 out of 9 that I pick a nickel. And to calculate probabilities, we multiply them together. So we will get a dime and a nickel with probability 25 out of 90. So 25 out of 90 times, we're going to get ourselves a dime and then a nickel. Similarly, 25 out of 90 times, we're going to get a nickel and then a dime. Makes sense that this is sort of the same. And then 20 out of 90 times, we're going to get a nickel and then a nickel. Okay. And we do the same sort of thing. You'll find it's 20 out of 90 times that you get a dime and a dime, but we don't really care about that because we're just trying to figure out the probability that we get 15 cents or less. So now we want the total probability. Well, none of these outcomes interfere with each other. They're all mutually exclusive. You can't pick a dime and a nickel and also have picked a nickel and a nickel. Doesn't work like that. So we can just add these up, and that's why I've left them all over 90 instead of divided by 5s anywhere. So we can get 25 plus 25 plus 20 is going to be 50 plus 20, or 70 out of 90, and I would reduce that to 7 out of 9. So 7 out of 9 times we will pick coins that total less than or equal to 15 cents. Okay? And that wraps up question number 1. Join me in the next video as we take a look at another 2-parter with question number 2.